In part 1 of the RFC forecast model outline, we covered the SAC model. Here in part 2, we'll be covering the unit hydrograph, river routings, and the rating curves. The unit hydrograph is based off the shape of a basin. Say we theoretically get 1 inch of runoff over the entire basin, and there's no interflow or base flow. Well, the unit hydrograph is what the hydrograph would look like at the basin's outlet. Unit hydrograph is for a perfectly uniform distribution over the entire basin and a uniform rainfall rate over an entire model step. To remind you, our model uses a 6-hour time step. The unit hydrograph is then multiplied, added together, and reshaped to get the end result. In this example here, the unit hydrograph is the dark blue hydrograph with diamonds. So in the first time step, we get 1.2 inches of runoff, and that produces this pink hydrograph with squares here. So you can see that it's just the same volume as the unit hydrograph multiplied by 1.2. Now in the next time step we get 2 inches of runoff, which produces the yellow hydrograph with triangles. So that is the unit hydrograph just multiplied by 2. Now all of this is behind the scenes stuff. The blue hydrograph is the one that would actually be output, because it is the pink hydrograph added together with the yellow one. So we can see how the unit hydrograph is multiplied, added together to get the end result, but how is it reshaped? It's reshaped through manual modifications that the forecasters make. Say if all the rain falls right next to the gauge, we might take that unit hydrograph, preserving the volume, but just scooting that volume all up front so that it will be a higher, faster unit hydrograph. And then that is what would be multiplied and added together. River routings is how the model gets water from one point on the river down to the next. We use the modified Muskingum method. It only has 2 parameters, lag and K. K stands for attenuation. Lag shifts the hydrograph forward in time, and K, attenuation, just stretches it out. So in this example to the left here, this is only lag being applied to the hydrograph. So we have our observed hydrograph upstream, and we apply a lag of so many hours and expect it to show up downstream just like this. Now in the middle hydrograph, we've only applied attenuation and no lag. Attenuation represents the temporary storage in the river reach of a river rise. So one way to think of it is if that upstream hydrograph is like a stiff wire and you grab it and just stretch it out, that's a shape that you would get for your attenuated hydrograph. Now when you do both lag and attenuation, you end up with this. This is what we have observed upstream. We apply both lag and attenuation, and then this is what we forecast to show up downstream. Now this is a simplified example because it only has 1 lag and 1 K, but both of those are variables, so we will have different lags and Ks at low flows versus high flows. Now the rating curve is something that we normally get from the USGS, and it's very important. It's based on channel characteristics. It converts from stage to flow, and from flow back to stage. You can see here on our y-axis we have stage in feet, and here on the x-axis we have flow in cubic feet per second. So if our gauge gives us a reading of 18 feet, we know we're at minor flood stage. We apply that to the rating curve, and that converts our flow to about 42,000 cubic feet per second, and then that's what goes into the model. Because most gauges read stage, i.e. river height, but our models only deal in flow. Each basin outlet has its own rating curve because no 2 points on a river reach are exactly the same. The rating curve changes over time, often during floods, due to erosion, deposition, and debris buildup. Now to show how ratings and routings interact. Say upstream we have a gauge reading. This gives us a stage. This goes into the upstream's rating curve, and then gives us a flow, which then goes into the model. Now the model does its thing, and then it routes that flow down through lag and K. when that forecast flow shows up downstream, it's put through the downstream site's rating curve to give us a forecast stage, and then that goes into the forecast. So you can see how this forecast is affected by two separate rating curves. So if either of them is off, forecast quality is going to be affected. To review, the unit hydrograph is a theoretical hydrograph. If 1 inch of rain fell uniformly over the entire basin over the course of 6 hours, and if all of that rain was converted into runoff, it would produce the unit hydrograph. This unit hydrograph is multiplied, added together, and optionally reshaped to get the final output. We use the modified Muskingum method to route water from upstream sites to downstream sites. It has two variables, lag, which moves the hydrograph over in time, and K, or attenuation, which stretches the hydrograph out. The rating curve is based on channel characteristics, and like those characteristics, it often changes. It is used to convert from stage to flow and flow to stage. It's also important to note that routed forecasts can rely on two rating curves, so if either of them is off, the forecast quality could be affected. For more detail, you can check out these links here. In Part 3, we will be briefly covering real-life complications and model limitations.